I'm gonna explain in my interpretation the correct way to make knife. We are gonna use the Argentinian knife because I think it's very good to get all the different steps and different points. So you can use this technique in other different knives. The explanation that I will below is based on my experience and is also from different books that I read during my life and different forging techniques. There may be other methods and they will not necessarily be incorrect, but this method that I will explain may be very useful to all those who are starting in making knife and make tools with edge. The forge for me is mainly based on the generation of preforms that later in the final stage will lead us to the desired piece. It is important that these preforms are organized in step and with the correct intention to be able to get the piece in the shortest amount of time possible and with the least amount of work and risk. I also discovered that the longer you work in the piece, there is more likely we are to make mistakes or overwork the material, incorporate faults or mistakes by the number of times that the piece was hit and cooled, in some cases generating damage to the material that is not possible to solve. For this, it's important to start talking about the material. We can separate materials into ancient and modern materials. Today, we are going to talk only about new materials because the other ones need the entire chapter. We can separate the steels in carbon steel and alloy carbon steels, for example, stainless steel. Iron is the main material. Carbon is the material that will provide the correct structure so that carries hardness. Phosphorus and sulfur is the two compounds that will be our enemies in the forge, since the first will generate structural problems in the material, making brittle and fragile. The second will generate iron sulfide, which is unweldable. So if we are going to make Damascus, we are going to have many problems with this. So the first drawing I have also here, this is the iron carbon diagram. I translate this to English and Danish if you want, because I couldn't find the same drawing on English. This is on Spanish, is from the book. You can see the name here. And I find a very great drawing because you can find all the information you need to work any kind of steel. We are going to use the carbon steel, not the stainless steel, because they work in a different way. So we can see here the amount of carbon in the steel. We are going to work always from 0 to 2%. More is cast iron, so we can work with that. And here in 0.8, we can see when the steel changes the structure and gets not magnetized. And we are going to talk later about this. And we can see how the forging temperature, and for example here, goes up when you have less carbon, and then it's constant from 0.8 to 2. Also the welding temperature you can see here. So I find a very great drawing. Talking about the steel, it's important to talk with the supplier to get the table about the steel. It's called datasheet. There we can find all the information of how to work the steel we get, because normally different suppliers can be different steel, and it's important to know which steel we are using. For example, for stainless steel, the 300 series in the ISSI is for structural steel, so can be tempered or can be hardened. The 400 series can be tempered. Maybe the most famous steel in this series is the 440C or chromium 18 steel. Is very used for many tools and knives. Another important aspect is the temperature, both the working temperature and the change that occurs in the material at different temperatures. And that we'll use for the various heat treatments and manufacturing process. I have translated the table, this one, and we can see also in the second drawing, when forging steel is important not to overheat the steel, as the grain size grows exponentially at temperature after the critical point, making very brittle. This is why it's normally mentioned that steel should not be burned. High carbon steel need a lower temperature for this point, so it's important to review the iron carbon diagram. For example, in this drawing, we can see how here is close to the temperature we have in this part of the drawing, is where you can cementize, normalize, or make all the heat treatments. And then we can see how the grain start to grow. In this green line, we can see how it grows exponential. So it's important to keep the right temperature because it's very easy to burn a high carbon steel if we often use a mild steel, for example, for work. Here I have it is, and you can see how it's burned and how big is the size of the grain. I have a photo so we can see better in a moment. Here we can see two photos. The first one is the color for forging, and the second one is when we temper or we hard the piece, then we temper, and we are gonna get these other colors. But something important about the heat colors is that we see different colors. So if you try to find this heat colors diagram or photo, it's gonna have different colors. Every photo you find on internet has a different color, and depends of your workshop, the light you have, and if you were outside or inside, you're gonna see different colors. Even if you are blind color, you're gonna see your color. So I find it's very handy to have, but you can't use this as a general rule because maybe for you it's different. So we are gonna keep in mind that practice and making samples is better than try to follow this kind of diagrams. We are going to use this design. The name of the knife is normally Facon or Verijero because it's using the verija that is in the front of the leg and comes from this design. This design is from Spain, from the Canary Islands, but we changed the design with the time. This is from around the 1800, around that, and it's a knife for work, normally for farmers or people who works in the field. So it's more like a tool and not only a knife for cooking or eat. But we changed the design when the colonies from Spain, for example, Uruguay and Argentina, they get the independence. So Spain start to commerce with us. So you have in the south of Brazil, Uruguay, and Argentina, almost the same design. We changed a little. Uruguay has his own design, and the south of Brazil also, they have his own design. But for Argentina, we have almost these 5 different knives. The long one we put in the horses, and normally it's made from swords. But we are going to talk about the little one. I have one here, for example. It's like this. It's very small, but has the right size for almost all you need. In the farms, we normally use this one. It's the Facon. It's a little longer. So I'm going to start to talk about how to make the knife, and then I'm going to explain all the parts in the knife. The Argentinian knife has a design that will allow you to organize different stages and shapes, the correct way to approach them. The design is widely used and is a universal work in the farms. The bolster has a lot of material to give more strength to the entire knife. The back of the knife is very thick, from 3 millimeters to 8 millimeters approx, while you see 5 to 7 normally. The back of the knife, we have the edge here, and this part is normally like 5 to 7. I normally make between 7 and 8. This is because in some occasion it uses a hammer, normally for nails. Also, the angle of the edge change from the tip, where it's sharper, to have a better cutting capacity, but near the bolster is thicker to be able to cut wire or bone more easily. There are 2 ways to make a knife. We can start with the tang and then forge the blade, or we can start with the blade and then forge the tang. This will depend of the design of the knife. Since, for example, in this model, if we start with the tang, then we will not be able to have enough material for the intense work in the blade, and the tang will break. So we are going to start with the 20 millimeters bar from SAE 9260 steel, which is a silicon manganese steel with 0.6 carbon that is used in trains and truck springs. To work the material, we are going to use a tank that allows us to hold the bar from the end. The first step will be sink one end to the forging temperature of the material. We will forge a square point in the end, taking special care that not to form a fish mouth, since later it will generate problems in the tip of the knife, and when the material overlaps, it can be difficult to see in future steps. If it generates, it will be better cut this part as not to introduce possible fissures. It is extremely important to respect the forging temperature and not forge aggressive, as this could generate cracks and stretch in the material, generating a defective part. We can see here how the cracks start to become. This is around 5 millimeters, but we can see here how the cracks, if we keep forging and we not correct this, here is like 20 millimeters long. So it's gonna start to grow. And for example, if we finish the knife and we temper, we are gonna lose all this part. So it's very important to keep in mind that we have like a fresh material. The next step will be turn the piece 180 degrees and force the other end. We can use a hammer or some type of tool such as guillotine or similar. We will seek to separate the spike from the blade and approach the shape of the bolster. From this, we will forge 4 sides for the tank and only 2 to generate the neck of the blade. Ideally, we use a guillotine tool as a radius of approximately 8 to 12. I prefer 12. Using a smaller radius can generate cracks due to the treating of the material, since it's very aggressive force if a hammer of more than 1.5 kilo is used. So in this case, we can see here is around 6. So if it's very sharp, I don't often like this because it can generate cracks here when you get thinner. We can see here, for example. Also, if you work with the guillotine, it's important to keep in mind the thickness of the blade you want to get. Here is around 5 millimeters now. So if we want to have a 5 millimeters blade, is not okay because we are gonna get maybe 4. We need to keep some material to work later, and it's better to have, for example, 10 than a very thin material, because when we work all this part, this is gonna break because we are gonna maybe move the piece or start to bend sometimes, and this is gonna get the crack here. So we are gonna try to use the bolster as a connection between the blade and the tank. And it's important that all the area close to the bolster is the stronger part always. And like I said, when you get thinner with the blade, it's very easy to overheat the piece and burn the steel. So please don't burn the steel. Keep in mind the forging temperature and follow always the data sheet of the material you have, because different steel have different forging temperatures. Even if they have the same amount of carbon, for example, you can have this with the stainless steel. Normally, the stainless steel for making tools is like 1.2 carbon, but for example, for the heat treating is like 1000 degrees, and normally is close to 800 if you have a carbon steel. To make the blade, we are gonna use this special hammer. In English, is called like dog hair hammer, but you can also find in many different cultures. For example, you can also know this hammer from the Japanese culture, but this is made from the mastermade fine in Gotland, in Sweden. Is from the 1092 and is from the Viking era. So many cultures in different countries use this hammer, because I find this probably the best hammer you can use for make blades. I have this hammer here, and I'm gonna try to explain how it works. This hammer is like 800 grams weight, and we have the center mass here. But as you can see, the handle is bent. So when we catch the hammer like this, the hand is in the same line of the gravity center. So we can control very well, but this hammer works. At the beginning is very weird to use, but then you find how to use it. Because it's round, you can hammer in different position, and the shape is gonna be also always the same. But the good thing about has have all the weight in this area is that self-correct when you hammer. So normally, if we use this kind of hammers, the center of gravity is like almost in the middle or in the center. So there is not different if you hit with the hammer in different positions because you are always in the center of gravity. So your skill is applied in this hammer. If you don't have a good technique, you're gonna sit in the piece because you're gonna change a little. But with this hammer, it's gonna correct because this hammer always try to hit in the same position. And we are gonna use always this part. So it's like a cross-pin hammer. And then we are gonna try to go up a little and get the flat in all the blade. So it's very handy to make knives. And I think this is why you can find in different cultures. Talking about how to forge the blade, I always try to keep material in the edge. We are not gonna try to get all the shape of the blade because, for example, I have this stage here. We bend the knife going back, the edge is gonna be here. Because we are forging the edge is gonna get longer, so the tip is gonna go up, and we are gonna get the correct shape of the knife. But we have a problem because if we hit here, it's gonna get very thinner, very fast. It's gonna cool fast, so it's very easy to get very cool. So it's gonna, maybe you can make it crack, or you can have problems because it's gonna cool very fast. So if you forge like this and you keep some material in the edge, this is of course over exaggerate, but is to keep in mind. We keep some material here. So when we get all the flat, and normally I make the knife like a V shape and not different stage because this is more easy to sharp. You get a very sharp edge. The other way is very commercial or industrial, and I don't like because I prefer a tool that really cuts and not one that is easy to sharp. So we are gonna keep this in mind. So we are gonna go with the tip. I have the stage here. We make the four faces, the square point. We put down this one, and then we start to forge all the blade all along. In my particular case, I never preferred hit the edge side. It has little material and can bend and generate micro cracks, which can later cause problems with intense use, creating indentations to come from the initial problem. It is something that can be completely avoided following the next steps. We are gonna bend the knife going down like this, because if you get the knife like this straight, and you make the shape, the edge, the point is gonna be up, but then you have a lot of material here, so it's gonna go up a lot. And you need to hit this part to go down again, or I see sometimes people that hit edge like this, trying to get straight again. But I don't like this because if you get very thin with the edge, and it's very difficult to know when is too thin, maybe 2-3 millimeters, you're gonna bend the piece. So the edge is very thin and it's gonna bend like this a little. And then you strike. It's okay, you're gonna see the edge and it's gonna look very nice, but bending this too many times is gonna make it crack. Normally it looks like a semicircle, like this. And then when you use the knife, it's gonna break exactly like this. So I have a special way to get the right shape. I hit using the horn of the anvil all the way, then the half or 3/4, then the half, then the last quarter. So I'm hitting more times the tip, and I'm gonna get from the 8 millimeters to maybe 0 or 1 millimeter in the tip. So it's a very easy way to get the right shape. And the next step is going down with the tip like this. And then we are gonna start to force from the bolster area to the tip, all the edge. We can do this many times as we need. For example, here, I make one time, and we can see the tip here is with the problem. We are gonna see here sometimes many problems in the blade, but I try to learn making mistakes. And when you make mistakes and you trying to find a way to correct them, you learn something. So it's important to keep in mind that this is sample piece and it's gonna use to learn. So for example, using a very sharp guillotine, we get this shape here, and it's very tricky to get the right shape later. Normally people use the sander to grind this and remove the material, but we are gonna try to find the right way, and is using, for example, a 12 millimeters round bar or in the guillotine. So then you get some extra material here and you can correct this. So with the first hammering process, we get this straight line, and we can see how from this shape, we get the tip almost straight. We are gonna make this a second time to get the tip in the same line of the tang. In this design, I have a finished one here. The tang, the bolster, and the tip of the knife make a single line. So we are gonna try to hammer to get the tip to this line. But now we are gonna force this area because we have a decoration, and it's this one, for example. We are gonna try to put material over the bolster, and it's a way to show, in one way, the skill of the blacksmith, because we are gonna pull material in this direction. And in the other hand, it's a way to stop the hand to go to the edge. We have here a different step. For example, I correct here the line, and we have two ways to make this. The first one is, if we have a crosspin hammer, we can hit here and use the anvil in this area to move all the material back to the anvil. So we correct the line like this. I use the crosspin hammer here, and then I get the strike. But you're gonna always keep this problem here. So it's better if you use the 12 millimeter bar. So we want to work here. This hammer is great for this because we are gonna start to pull material in all this direction. So we are gonna use the handle as a guide in which direction we are working. So we can correct with a lot of precision the direction of the hit. So this is the way we are gonna turn the handle around the edge to pull material to this area. And we can also start to hit in this direction to get more material here. And this is why it's important to not go directly to the edge. We are gonna start to have like 4 millimeters, 5 millimeters, so we can have a lot of material later. This is the way I try to hit. I use a drawing because it's easy to explain. It's very difficult to see in the piece. So we start to pull material like this, and we turn the hammer. So if you see like this, I start to turn the hammer following the direction I want. So with this hammer, it's very easy to do it. We have a different stage here, and I'm gonna start to work in this area. We have a closer view here. In this case, the bolster, later I'm gonna use the file to remove the material here and get the square like this, something like this. Normally, we use wood, bone, or a silver like this to get the handle. So we need the flat in the back of the bolster to put the handle. So here, I move all the material in this area, and then I use a file, I think was like 6 to 8 millimeters round file. And I also file all this area with the same round file to get a very beautiful shape here. We can see a closer view. I start to work here also. It's very important that you don't get a very sharp edge here, also in any part of the knife, because when we temper the knife, could be a weak point. We don't want any 90 degrees or very sharp edge in the blade. We can see here a different kind of bolster. This is very famous in Uruguay. Has this round shape, and we always make with the file also. If we have some problems in the line of the knife, we can hit to the right temperature and use the vise to correct the direction. So we are going to try to get the straight in this line. We can also use the tang. We clamp the tang in the vise and we hit the bolster. We can use a bullet hammer also. It's a great way to avoid any heat here. And now we can talk about the heat control or the heat temperature. This is a very famous photo from internet, but we can see when we overheat the piece, the grain starts to grow and has this shape. And you can also see in this part, the grain is very big. So I use wood to explain how the steel works. A hard wood has a very short grain and the soft wood has a very long grain. So with the steel is also the same. If you have a very big grain, it's going to be very weak because the connection between the grains is lower than when we have a very small grain. So when we finish all the forging process, we are going to do the normalization process. We hit to the critical point. This depends from the steel, and we hit 3 times and let cool as low as we can, and then we are going to temper. For temper this knife, I'm going to use oil because it's the correct cooling method for this steel. And we are going to put in this way, like an angle, and only to this place. We are going to keep soft all the bolster area and this area also. So we are going to harden all this part of the knife. To be able to harden, we must bring the piece to a critical point. The temperature at will the material change the structure and allows rapid cooling to generate the type of structure to give the hardness. From less cooling capacity to higher cooling speed, we can order as is follows: hot air, hot oil, cool oil, soapy water, fresh water, and salt water, and acid. There is also other methods such as the immersion temperature in borax or industrial process that are not applicable or comfortable for the normal workshop and are oriented to very specific characteristics of very reactive steels that are rarely used in forge. Thanks to the salt water and the correct temperature, it's possible to temper low carbon steels like mild steel, data we can also obtain from the iron carbon table. Oil and soapy water temper at similar speed so they can be replaced in case where are one or other liquid not available. There are many home methods to find the correct temperature for forging, and care must to be taken that they are applied correctly. From the iron carbon table, we can find that the magnetic change occurs in the steel at 70-68 degrees. We can also see that temper range coincides with that point the steel from 0.8% of carbon. So for example, the C97 steel can be tempered using the magnet, bring the magnet closer, and where it's not magnetized with the steel, it will the correct point to temper or hardening. But on the other hand, we will not be able to use, for example, C70 steel because the current temperature is like 800 degrees. With a lower carbon steel, the difference is even greater, reaching difference from more than 100 degrees. And this is, I believe, the reason with many people believe that there are no hardness steel or without less characteristics. This metal and other hand is very good to be able to train the eye at temperatures or in different temperatures. So the next step after quenching or in oil is the tempering process. We are gonna clean the edge and we need to temper the blade as fast as we can. I'm gonna use the forge and I wanna use always the edge going up to hit very slowly. I'm gonna start with the bolster area, and when I close to the right color, I'm gonna start to move very slowly to the tip to get all the blade in the right temperature. Because I normally do traditional blacksmith, I don't wanna use a treat oven, but of course it's the best option if you have one. For this type of knife, I'm gonna use the straw color. I prefer a very hard knife because I always choose the hardness and the edge, but you can also use a more soft, but not close into blue because we are gonna lose all the hardness.
Thank you, Mariano, for this great presentation and lots of detail, lots of probably for people interesting in you at least.
I'd never heard of using soapy water as
Yes.
a low speed quench.
You must try it.
So how soapy are we talking about, and where did you learn this?
I learned from Ramon Recuero from Spain. They use a lot in the past. I think maybe they have some problems with oil, but it was an old technique.
And
so you just
how soapy?
It's very difficult to say, but it's better if you try. If you cut to the half a piece of soap and like a 25 liters pack, around that.
Yep.
Maybe a little less, but it's around that.
5-gallon bucket.
Yeah.
Okay, that's
works
awesome.
very great. It's the same with the salty water. If you have a very low carbon steel, like my steel, it's so great. It's changed everything. Because also, if you want to work very fast, you can use for quench very, very fast this.
And that one I know, it gives you a very fast quench, which is the basis of Rob Gunter's super quench.
Yeah.
Where you're using a degreasing, very wetting, strong brine to get such a fast quench that you get hardness without carbon.
Yeah.
Well, for both very nice and interesting to learn about knife forging.
Why did the Argentina people change the form of the knife?
Well, the design from Spain has a very thin blade, like 3-4 millimeters, and it's very wide. It's not that small like this. Try to be longer like this because they try to have a knife to the whole life. So it's very easy to use for a long time. But because in the past, the tools were very expensive in Argentina and the farms are very, very far, they try to use only one tool, or they try to bring only one tool. So the normal decision is a knife because you can use for everything for cooking or for example, for kill an animal or whatever. But because bring a knife, bring a hammer, bring a tongue, it's a lot of tools. They try to go or travel lightly because it was the people who work the farms travel around all the country helping different farms. So they try to travel lightly. And we changed the designs and we make a very big bolster like this. Normally, if you buy a modern knife or a modern Argentinian knife, the bolster is very thin. It's closer to the design from Spain, but the old ones has a very big bolster. Try to get the strong part here and not break the tang. And we try to get more material here for 2 reasons. The first one is many of the old blades are made for breaking swords or other type of weapons from the war. So they are very thick. So we keep this as a tradition. In the other hand, you can use in different ways. So if we have here like 7 or 8 millimeters, you can use as a hammer without problem because you can really hit a nail with this. It's not problem. But if it's very thin, you can do it. So it's better if you have this one. But because you have like a D shape also here, this part, the tip of the knife, is also thinner. So you have a great cutting place here. And here also it's very thick, so you can use for cut wire or whatever you want, because it's a stronger part. It's more like an axe, if I can say like this.
It's interesting because you would think that the Spanish form is the proven form, and yeah, when they go overseas, you see other people try to improve the technique. It's interesting. Yeah, thank you.
Yeah.
Marianne, I just came very, very late because my computer didn't work. But I would want to ask you, you wrote that you needed to heat 3 times, or am I wrong?
Yeah, I hit the knife to the hardening point, or when you get the right structure, you get this from the data sheet of the iron carbon diagram. And then you cool very slowly, like you put an ash or in sand or wherever you can find to cool very, very slowly. And then you make the same again. 3 times, 2 times is okay. You can also make 1 if you want, but it's better if you make more times. You can see in the photo, and you can see you're gonna have the PDF later on internet, so it's okay. How the grains goes thinner or small. And this is very important because maybe you overheat the part, or you heat too much the part and the other no, so you get all the structure homogeneous, I think it's called. Yeah, it's a way to prevent problems in the future.
Yeah. So you heat 3 times slower than 1 time hard, or am I wrong?
You get the temperature and you put an ash, so it's gonna cool very slow. Maybe it takes 3-4 hours to get cool. Then you put again in the fire and you this 3 times. And the last time, the time number 4, you put on the oil to harden the piece. And then you temper the piece.
Super. Thank you very much.
So I remember when forging a blade, we had this in school. One was supposed to get as little amount of heats as possible. So how many heats would you normally, like, of course, how many heats do you need? But what would be the aim one should go for?
I'm gonna try to explain with the steps. The first is this one, to make the point. Because it's 20 millimeters, you really can make this in 1 hit if you have the skill. The second one is gonna be this one, and the third one is gonna be this one. And then for the entire blade, you're gonna need between 2 and 3, I can say.
Wow.
Yeah, with working with the horn of the anvil. Without the horn is very tricky. And I don't want to use the crosspin hammer because it's very aggressive. And I think here, yeah, here. I don't know if you can see, but here I have a lot of cracks.
Mm-hmm.
So it's not that tricky to get the cracks. So it's better if you take 1 hit more and not to try to work very fast. So we get this shape, and then for make the edge between 2-3 hits, because you're gonna work like this in the first one. Maybe you can work the whole blade, but it's very tricky because you get thinner. So I think like 4 times, 5 times is okay to make the edge of the blade. And then you need like the 4 or 5 for all the hardening process, and that's it. So you can make a knife in like 1.5 hours without the 3 cooling process. This is the good thing about work with the very thick material. If you work with maybe a 5 millimeters blade, then it's very tricky because it's gonna cool very fast. And for example, I don't like very much work with stainless steel because need to lot of time to get the heat, cools very fast, is air quenching, so it's like no go.
It hurts.
And it's very hard to work. So it's
Yeah.
like, no, why?
It's like, no.
Something important I can say about the blade. You can see here a very black blade, and this is because you can get two oxidation in iron or high carbon steel or carbon steel. You can get the orange one, and you can see this one, and this is the bad one. You need to remove this, but the black one is gonna prevent in the future that the blade got oxidized. So we try to use and not to clean all the black oxide. And this is gonna help in the future to protect the knife, in fact. So it's very important to get this black color and not the orange one. The orange one is gonna destroy all the blade.
Can you show us the handle and how it's put together?
Okay, this one works like this. You have the spine, the tongue here, and you rivet from the back. And because I was waiting the question, we use, I think it's in Spanish is lacre, is the red one you use for
Okay.
chiseling and repoussé. Yeah. So we make the strong one, a very hard one, and we fill all the handle. And when it's very hot, we put the blade, and then we rivet here.
So inside is the
Yeah.
chasing and repoussé.
Yes.
So that's actually still inside the handle.
Yeah, exactly.
Oh,
So
okay.
it's also
Nice.
very easy to remove the knife because you file this part, and yeah,
Right, that's so neat. I would never imagine. Okay.
yeah, you have 4 compounds to make this red thing. Well, 5, because the number 5 is the ones to get the color, and is iron oxide. But you have the wax from the bees, you have the fat, you have the talc or calt, I think it's called, and the other one is the resin from the trees, the pines. So the talc and the resin get the hardness, and the other 2 get the soft. So you make a mix with these 4, and you get the right one. For chiseling and repoussé, you have one for the winter and one for the summer, but in this case, you try to make a very hard one.
Mariano, das Ingriff, ne, ich weiß, du verstehst mich, ne, ist aber normalerweise kein Treibkit. Da gibt es 2 verschiedene Füllungen. Eine reagiert so auf 50, 60 Grad und eine auf 75. Ja, das ist gerade für die Spülmaschine entscheidend. Ne? Aber ich kann kein Englisch. Ja.
Otto was saying that there are different kinds of this kind of material. Treibkit is the German. I don't actually know what is some kind of pitch. Is the
Pitch.
English word?
Pitch.
Yeah.
Pitch, yeah.
So there are different kinds of pitch which react to different temperatures. Some react to 60, some react to 75 degrees Celsius, whatever this is. The thing is that what he was saying also, that this might be interesting if you make something which goes to the dishwasher. Maybe you don't put your knife, you have this kind of knife to the dishwasher, but maybe you use this for something else, and then it might be a story. Nochmal, ja?
Deshalb, wenn ihr gutes Besteckset habt, sind die Messer und die Griffe aus 2 verschiedenen Material. Und wenn ihr Spülmaschinen habt, die sehr hoch fahren in der Temperatur, dann seht ihr als mal bei guten Bestecken, ne, die aus 2 Teilen gemacht sind, weil das Messer muss ja aus einem besseren Stahl sein, eigentlich wie der Griff, einen Spalt, und der wird immer größer werden in der guten Spülmaschine, die Temperatur sehr hoch fahren.
If you have high quality cutlery stuff like forks and so on, of course in high temperature dishwasher, of course you would never put your knife there, but if you put this, you know, there are people who do, so it might be interesting depending which kind of customer you're anticipating. So, of course, with very good cutlery, the steels are different for the handle and for the blade. And over time, you see a dent, like an opening, like a gap forming.
Yeah.
And this is due to that reason that the high temperature removes or like opens this up in some cases.
Yeah, because the page normally when you heat gets bigger, so it's gonna leak from the sides. So I prefer always clean the knife by hand and remove the water as fast as you can. Das ist schon.
Ein gutes Messer gehört nie in die Spülmaschine. Warum auch? Saubere Lappe
Endlich,
ab,
endlich,
Altöl,
gut.
gut ist. Sorry.
Und das ist Hilfe.
Ja, hat gesehen,
Sehr
Mariano.
teuer.
Ich kam zu spät, leider. Ich war im Hammer.
It's too expensive.
Yeah. And don't put silver to the dishwasher and all, you know.
I just want to thank you for those fantastic pictures of the fish lips to cold shut to the crack propagation.
Yes.
That's beautiful. That is such a powerful teaching tool.
And this is because if I make a knife without any problem, nobody is gonna learn anything. If I make all the mistakes and I show the mistakes, you can learn why the techniques goes in this direction and not in a different direction. Because I can find many videos and people start to hit every place, and in some moment they get a knife, but it's like 20 days. Or the other thing I don't like is they try to make like a very roughly shape, and then they grind everything. And then it's like you waste the half of the knife in dust. So if you make right, you can like use a file for 2 minutes and then it's ready for quenching. So it's also ecological if you want.
It's cheap or less expensive. Thank you again, Mariano, for this great and detailed presentation.